space isn't actually an ordinary vacuum. Every cubic centimeter of space contains an average of 5 to 10 atoms. I was quite surprised when I first learned this. For comparison, the air in our lungs when we breathe contains trillions of times more molecules than that. In other words, space is nothingness. Even sound can't travel in this nothingness because, as we all know, sound requires molecules, matter, to propagate. So what happens to temperature in such an empty environment? Temperature is measured by the vibration of atoms, meaning it's related to their kinetic energy. And if there's almost nothing there to vibrate, the temperature is low. Now, I ask you to close your eyes and do a thought experiment. Take a piece of metal in your hand and heat it. After a certain amount of time, the metal piece will become very hot. The reason for this heat is that the atoms inside the metal begin to vibrate a lot due to the heat. A thermometer measures this motion and shows the temperature. So, what if there is nothing in space, no air, no matter itself? Then, what is measured? NASA measures this using space telescopes and microwaves coming from all around the universe. Isn't that quite surprising? The sun we see in the sky every day actually converts millions of hydrogen atoms into helium through fusion every second, releasing an immense amount of energy. It emits approximately 386 octillion joules of energy every second. To put this into perspective, my own estimate is that this is far more than all the nuclear bombs on Earth exploding at the same time. So, how does such an incredible amount of energy almost vanish into nothingness after just a few million kilometers in space? Isn't that surprising? Actually, this involves energy-matter interaction. Since most of space is composed of vacuum, there are no atoms for this energy to latch onto, because energy propagation requires atoms. Now, let's do a thought experiment again. If we heat a piece of metal and bring our hand close to it, we can feel the heat. But if we take the same metal piece into a vacuum and bring our hand close, even though the metal is still hot, we won't feel the heat because there are no air molecules to carry that heat anymore. This principle also applies to the sun. The sun's energy is high, but unless that energy hits an object, there is no sensation of energy. From all this, we come to the point that anything that does not directly absorb the sun's energy hardly feels its presence. That is why space has a temperature close to absolute zero. The truly shocking fact is this: if we were in the vacuum of space, we could freeze and burn at the same time, because the side of our body facing the sunlight could heat up to 120 degrees Celsius, while the other side could drop down to minus 150 degrees Celsius. So, while one side of us burns, the other side could freeze. Our heroes in space, the astronauts, face this reality every day. Their suits are not just clothing, they are like armor fighting against this reality. These suits regulate heat and block radiation. Their suits have multiple layers, which shows us that these suits are armor woven with technology. When we consider all these topics, we understand that temperature arises as a result of contact. This phenomenon is one of the physical laws that surprises me the most. So, what is the physical law that surprises you the most? If you write it in the comments, we can discuss it. Thank you for watching the video until the end. If you liked my video, I would be happy if you hit the like button and subscribe. See you in my next documentary video.